As a final example of applications of exponential functions, we're going to look at interest problems. Here we have two equations we're going to look at that deal with interest. A in both cases stands for the amount after a given time. P in both cases stands for the principal. And the principal is the original amount that you start with in the account or in the loan if you're borrowing the money. R in both cases stands for the interest rate, and it must be written as a decimal in this case. N is used twice in this equation and not at all in the bottom equation, and it stands for the number of compounding periods. And by that, we mean how often do they calculate interest? So is interest calculated monthly, daily, annually? And that can play a big role into how much money you make on an account or how much money you owe in interest. And then T, as you may have guessed, stands for time in both cases. You're going to notice this problem has what's called an E value, and this is a number that you can see on your calculator there that we use when dealing with exponents and something we'll talk about later called logs. And it's kind of like pi. It has a very special value of 2.71828, and it keeps going forever, but your calculator actually has an E key. You're also going to notice that N varies from problem to problem. It stands for the number of compounding periods in a year. If the value is calculated yearly, N is 1. If it's calculated quarterly, N is 4, monthly 12, weekly 52, and daily 365. So let's look at a couple of examples where we might apply these problems. If Sandy is investing $10,000 in a savings account, earning 4.5 interest annually, compounded quarterly, what is the value after 3.5 years? The only time you're going to use this formula is if it is doing something called continuous compounding. And this is why there's no N value, because it's compounded every second of every minute of every hour of every day. Here it's compounded quarterly. We're going to use the formula A is equal to P times 1 plus R over N to the NT. The A is what we're trying to determine. We want to know the value after 3.5 years. Her original investment is the principal, or $10,000, times 1 plus our R value is that 4.5, which we have to convert to a decimal, over N. N is quarterly, and if you remember, that means N is going to be 4. And then here we're going to have 4 times our T value is 3.5 years. I encourage you to plug this in as one step when you calculate this. You can do this using your Desmos calculator online or your own personal calculator. And when you plug this in and round to 2 decimal places at the end, you should get 11695.52. And I do encourage you to try that and let me know if you're having any calculator problems there. As a second example, suppose Sandy is now continuously compounding this account. This indicates to us that we are going to use that second formula of A of T equals P E to the RT. And in this case, our principal remains the same, 10,000, and then we're going to have E to the 0.045 times 3.5. Again, on your calculator, be careful to put that in parentheses. If you attempt to calculate that, you should come out with 11,705.81, which you notice is different from the value we calculated here where it was compounded quarterly. So the type of compounding account you have does play a role in how much money you will earn in interest or how much you will owe if you are borrowing.